Hopefully you're joining me at some point for this lesson. Lesson 21.A is a combination of some Algebra 2 and some Trig. So 21.A is on evaluating functions, and that's when we have multiple functions, functions f, functions g, functions h, and then they give us directions on how to apply those. So I'm going to give us our functions that we're going to use today. So our functions are the function of f of x, which is x squared plus x minus 10, and the function of g of x, which is negative x squared minus 3x. So example number 1, find the following. We're going to do several parts. So part A, what is f at negative 3? All right, so remember, this is asking us to substitute the number in for x. So I'm using my function of x, so that would go here, right? And I'm substituting negative 3 in for x. So negative 3 squared plus x minus 10, and I'm substituting a negative 3. All right, so that should give me what? 9 minus 3 minus 10, so that is a negative 4. So you could either just circle negative 4, or you would say f at negative 4, f at negative 3 equals negative 4. Either way, so you could write it just like that, or you could write it the function at negative 3 equals negative 4. Either one, okay? So part B, we're going to find g at 2. Now they mentioned g, so I'm using this function here, and I'm substituting 2 in for x. So hopefully you recognize this from Algebra 2. So that gives me a negative 4 minus 6. So I could say that g at 2 equals 10. Negative, or you could just circle negative 10. You could write it either way. It's really your preference. I would accept either. Okay. All right, moving on. I'm going to give you 2 new functions. Or should we keep it? Yeah, I'll give you 2 new functions. So we're going to change it up. The function of f of x is x squared plus 1, and the function of g of x is 4x minus 5. So for these, I'm going to be substituting in my functions, not just a number. So find the following. So part A, find f of x plus 1. So for here, instead of just substituting a number, I'm substituting an entire function. They mentioned f, so I'm using f. And so I am substituting x plus 1 where x is. So instead of substituting just a number in, I'm substituting this whole function. So then I'm going to simplify, right? That's x plus 1 times x plus 1, and then out here I have plus 1. Now hopefully you get pretty good at simplifying a binomial squared. I know it's going to be x squared, x times x, and I know I'm going to get positive 1 from 1 times 1. But the 2 middle terms are going to be 1x plus 1x, right? Because they're the same, x times 1 and 1 times x. So I'm going to do that sum in my head and then bring down the plus 1. And so my answer is x squared plus 2x plus 2. Okay, part B, find g at 2x plus 3. So I'm using this function here, and I'm substituting the 2x plus 3 in for where x was. I'm going to distribute the 4. That gives me 8x plus 12, and I'm going to bring down the minus 5. And so my answer is 8x plus 7. Easy peasy, right? All right, so let's move on and use the functions in our reference triangles, okay? So here are, I'm going to give you 2 new functions. So this is similar to what you might see in your homework. So h of theta equals the sine of theta, and the function of g of theta is the cosine of theta. So right away, hint, 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 I'm going to draw my reference triangles. Okay, that's the first thing I'm going to do because I just learned that in the last section. I see sine and cosine. I bet you I'm going to need to draw my 45, 45, 90. So 1, 1, root 2, right? That's 45 there. And I'm going to need to draw my 30, 60, 90. So I'll just put 60 there. It's 1, 2, root 3. Now I do it in that order, short leg, hypotenuse, root 3. So here we go. Find the following. So part A, find the following. 4 root 3 times the h at 30 degrees. Now that looks kind of crazy. So first let's recognize that this says 4 root 3 times the function of h at 30 degrees. So I'm going to start here. H at 30 degrees is using the function of h. So I'm looking for the sine of 30 degrees. Okay, so if it helps, here's h. So here's h. The sine of 30, so if I'm looking at 30 degrees, which is here, right? 30 degrees is a small angle. Sine is opposite over hypotenuse. So now I'm going to bring down the 4/3 times 1 over 2, and that gives me 4/3 over 2. So my final answer would be 2 root 3. So hopefully you can see why the 4 and the 2 cancel. Part B, find 5 root 2 times g at 45 degrees. So I need you to recognize when they're all written like that, that is actually 5 root 2 times the function of g at 45. So I'm going to do that first. The function of g at 45 degrees. Up here, function of g is cosine. So that would be the cosine of 45 degrees. Cosine of 45 is adjacent over hypotenuse. Remember, I can rationalize now or later, but now I'm going to bring down the 5 root 2 times 1 over root 2, and that gives me just 5. So I simplify this part first. You can keep this out front if you like, but I'm simplifying the function first and then multiplying it. And so those are your answers. All right, let's move on. To 21.B, which is, we're going to go over a new way to write domain and range. Now you can use Desmos for this. You can graph your function and use that to do domain and range. So we're going to go over another way to write it, okay, and then how to pronounce it. So a couple symbols I need you to know. Instead of writing all real numbers, this symbol here, notice it has 2 lines and then your R. This means all real numbers. So we're going to be using that symbol, and it just provides us a shortcut of writing all real numbers. And then it looks like a C with a line drawn through it, and that means an element of. And so I'm going to go ahead and write an example of this. Okay, so an example of this new way to write domain and range is first you're going to see these brackets. Okay, now instead of writing domain, I would simply write X. So instead of having to write D or domain, I know that I'm talking about domain by writing X. Then I would use this vertical line. So that's a way of writing such that. So X such that I could write 10 is less than or equal to X, which is less than 30. So I'm going to go over what all of these things mean. So this type of way of writing your domain is called set builder notation for domain and range. This vertical bar right here, this vertical bar means such that. Because I'm writing X, write X instead of domain. And these braces mean that I'm writing the set of. So I hope you're getting the picture that in math, we're trying to use all these symbols instead of words because that's why we like math, right? It's not an English lesson. We don't want to write sentences. So this is the set of X, or your set of domain, is such that X is greater than or equal to 10 but less than 30. So we're going to be using set builder notation to define domain and range. Now you can use Desmos. If you graph something on Desmos, looking at the graph, you should be able to determine domain and range. I'm going to do some examples with you that you'll see in your work, and you can use my notes to help you. So find the, this is going to be the directions for all problems, sorry. Find the domain and range for the following. Now these are functions similar to what you are going to see. So again, use my notes. So f of x equals the square root of 10 minus x. So this is the square root function. You might need a little background for square root function, right? I cannot take the square root of negative numbers. Okay, so the smallest number I could plug in here, I know that the smallest number I can take the square root of is 0. Okay, so the smallest number I can take the square root of is 0. So that's why I'm setting this equal to 0. I'm going to subtract 10, and that gives me negative x equals negative 10. So x equals a positive 10. So for the domain, right, for the domain of f, I would write the following. X is the set of, that's what this bracket means. X is all real numbers such that x has to be, now this is where it gets tricky. I'm going to write a better R. Can I plug numbers in here greater than 10 or less than 10? So what is not going to produce a negative number? Well, this is 10 minus. 10 minus 10 would equal 0. So I cannot plug in, I cannot take the square root of a negative 1. So x has to be either less than or equal to 0 in order to not produce negative numbers. Okay? So there is my domain, if they asked for range of f. If you were to graph this, if you were to see the graph, I cannot I'm never going to get a negative number when I take the square root. So y is the set of all real numbers, but it's limited, so such that y is greater than or equal to 0. Because when I take the square root of something, the smallest number I'm going to get is 0. Because remember, I don't want a negative. So that is the domain. This would be your answer. Okay, so this is x is all real numbers such that, then you write all your limits. So next one. What is the domain and range of g of x divided by 1 over x minus 2? Now remember, I cannot divide by 0. I'm not even going to add to that. Okay, so I have to ask myself, what would be the limit here? What number could I not plug in? Well, I could not plug in x cannot equal 2 because it would produce 0. Okay, so when I go to write the domain, x can be x is the set of all real numbers, but I'm limiting it to the value it cannot equal. And in this case, x cannot equal 2 because 2 would produce a 0. Now for y is also the set of all real numbers. However, what am I not going to get? Okay, if I divide 1 by 700 and 1 by negative 700, when I divide, I never get 0. So y cannot equal 0. Again, if you need to graph these to help you, that would be fine. Let's start real basic. Y equals the square root of x. Okay. So let's talk about x. X cannot be negative. And if we talk about y is never going to, the square root of any number won't be less than 0, right? The smallest number I'm going to get is 0. So I would say that x is the set of all real numbers such that, now I have to list my limits. X cannot be negative. So if x cannot be negative, it could be greater than or equal to 0. Y, if I'm taking, sorry, I wrote x again. Y is also the set of all real numbers such that if the smallest number I'm ever going to get is 0, then I would state that y is going to be greater than or equal to 0. The smallest number I could enter here is 0, and the square root of 0 is 0. So all my answers for y are going to be greater than or equal to 0. Okay? Now I'm going to do a couple more with you because it gets pretty crazy as the sections move along for domain and range. So h of x equals the square root of x plus 4. Now, I'm still dealing with square roots. Remember, I can't take the square root of a negative number. So I have to figure out the smallest number I can take the square root of is 0. So what x value is going to produce that? That'll tell me what x needs to be greater than. So if I subtract, I can say x is a negative 4. So I can plug from negative 4 plus 4 would equal the square root of 0, which is 0. So I'm going to make a statement about that. X is the set of all real numbers such that x cannot drop below negative 4. If I drop below negative 4, that's going to give me the square root of negative 1, and that I cannot do that. So x cannot drop below negative 4, so I would make a statement that x can be greater than or equal to negative 4. It can be equal. I can plug in negative 4 and still get an answer in my calculator. Now, the smallest number for y that I'm going to get is still 0. So y is the set of all real numbers such that y is greater than or equal to 0. And I know that because that's the answer I got here. Now let's try a more complicated one. F of x equals the square root of x divided by x minus 3 and x plus 1. Okay, now this has multiple pieces. Sorry, I'm having to unlock my computer. So I have multiple, I don't know why I put a bracket here. Okay, this right here would limit that I can't use negative numbers. And my denominator would give me my excluded values. Right? And what two numbers would produce 0? My excluded values would be 3 and negative 1. So I have to state that in my domain. I have to state this limit, right? X can't be negative. And then I have to state that x can't equal these two because that would produce 0 in the denominator. So I have two things going on here, or actually 3. So x is the set of all real numbers such that I know x has to be greater than or equal to 0. That takes care of this. Okay? I also know that x cannot equal negative 1 or 3 because those numbers would produce 0 in the denominator. So there's multiple things going on here. Now, do I need to state this? Do I need this? And I'm going to put that. Do I need this if, do I need, in case you're just looking at, do I need this if I already stated that x has to be greater than or equal to 0? No. I've already stated that x can't equal 1 in this statement. So the only thing I need is x is the set of all real numbers such that x is greater than or equal to 0 and x cannot equal 3. That's all I need. I've already stated that x can't be negative. Okay? And then y is the set of all real numbers. For this one, y can be anything because I can be more than 0 because I'm then going to be dividing it by something. So y would just be all real numbers. So use this for your homework. Use these examples. There is another part to this video, and so I'll do that part real quick. 21.C are types of functions. I don't think you need me to explain. Right? There's a function versus a relation. And what makes something unique to a function is that every x has a unique y value. Right? A relation is just any set of pairs. It doesn't really have a rule. It's really any relationship, set of values that have a relationship. So an example of that is if I had 7 and 5 and 3 and 4. Let's say if I plug in 7, I get 3. If I plug in 5 and get 3 one time, and I plug in 5 again and get 4, then that is an example of a relationship. But that would not qualify as a function because 5 cannot have two different y values. So this is not a function because 5 cannot have two different y values. What makes a function is that each x has one y. Now you can have multiple y values, so let me show you what I mean. If I plug in 0 and get 2, and I plug in 1 and I get 1, and I plug in -1 and get 1. That is okay because these are two different x values. So the 21 point C just goes over the difference between a function and a relationship. 21 point D goes over the test for functions. Okay, there are two tests, the vertical line test and now the horizontal line test. So a vertical line test, right? How many times can it intersect a function? It can intersect once if a function. You would use the horizontal line test for its inverse. If it passes the horizontal line test, then the inverse will be whether it will be a function or not. But you can also use the horizontal to know if it's a one-to-one function, if it intersects once. All right, for homework, since I ran out of room, for homework, 21, you're going to skip the following, number 2, and I just want to make sure, number 5, 13 and 14, 18 and 19, and 26. You're welcome. Goodbye.